Alright, hi everybody. Today we are going to do a quick review of our integer rules for adding, subtracting, multiplying, and dividing. We'll start with a quick review of adding, and there are several different situations that we may see with adding. Situations where the signs are the same, like a positive plus a positive, or a negative plus a negative. When the signs are the same, we want to remember that we're adding those two numbers together. So two positives, we're going to add those values together, and your answer will turn out to be a positive. For example, easy, 3 plus 4 equals 7. If we're adding two negatives together, a negative plus a negative, we're still going to add the two values, but the difference is that our answer will turn out to be a negative. So for example, negative 6 plus negative 8 will give us a value of negative 14. If you think sort of about a number line, which is probably how you guys learned this last year, you think about numbers that are below 0. If you're at negative 6 and you move negative 8 spaces, that means you're going to move to the left 8 spaces, which is going to land you somewhere down here around negative 14. Moving on, when the signs are different. When the signs are different, we're actually subtracting. The answer takes the sign of the number with the greater absolute value. Let's remember that the absolute value of a number is its distance away from 0. So if we are adding a negative plus a positive or a positive plus a negative, sometimes our answer is going to turn out to be negative, and sometimes our answer is going to turn out to be positive. So, look at that. So, let's say we are adding negative 12 plus 5. First of all, let's think about visually what that means. Visually, that means that if I'm down here at negative 12 on the number line, I am adding 5, which means I'm moving to the right 5 spaces, which is going to bring me to negative 7. If I'm adding a positive plus a negative, the same kind of thing may or may not happen. Let's say that I'm adding something like 11 plus negative 6. If you can think about a number line where 0 is there and here's 11, when I add a negative on the number line, I'm actually moving to the left 6 spaces, which is going to land me at positive 5. Notice the greater absolute value in the first example is negative 12 because its absolute value is 12. 12 spaces away from 0 is greater than 5 spaces from 0. So the answer takes the sign of the number with the greater absolute value. So we've got here a negative 12, and our answer turns out to be a negative. In the second example, 11 plus negative 6. 11 has the greater absolute value. It's a positive, and therefore, the answer turns out to be a positive. All right, it may look from my examples like it's going to be the sign of whatever the first number is. So let's take a look at one last example. Suppose we have something like negative 5 plus 8. So it doesn't matter if the greater absolute value comes first or second. I still know when I look at this example that the number with the greater absolute value is 8. It's a positive. I know my answer is going to be a positive, and I know that if I go negative 5 plus 8 is going to give me an answer of positive 3. All right, that was a quick review of addition. Let's talk a little bit about subtraction. By definition, subtraction actually means to add the opposite. Okay? When we set up a subtraction problem, and you probably remember this from last year, we want to make sure to make 2 changes to every problem. We're automatically going to change the subtraction into addition, and then we want to make sure that we change the sign of the second number. So we want the sign of the second number to actually become the opposite of its original. So let's say, for example, we're doing something like 6 minus 12. We'll start with something really simple. 6 minus 12, if I make my two changes, is going to become 6 plus, so I change subtraction to addition. This is a positive 12. Now I want it to be the opposite, 6 plus negative 12. Now I'm going to follow my rules for adding. Follow those same rules that we just talked about. 6 plus negative 12, once again, we're looking which value has which number has the greater absolute value. I see that negative 12 has a greater absolute value than 6, so I know automatically my answer is going to be a negative 6. All right, let's take a look at another example. Suppose I have something like negative 7 minus 4. Okay, negative 7 minus 4. I want to make sure that I show my two changes. So negative 7 minus 4 becomes negative 7 plus, and that 4 is a positive, and it's now going to be negative 7 plus negative 4. Following my rules for addition, a negative plus a negative, I'm going to add those two values, and my answer turns out to be negative 11. All right, let's do another example. Let's try something like 5 minus negative 9. 5 minus negative 9. So if I'm following my two changes, that is going to become 5 plus, the opposite of negative 9 is positive 9. Now I've got 5 plus 9. My answer is 14. Let's do one more example. Let's try negative 3 minus negative 7. If I follow my two changes, I've got negative 3 plus positive 7. Signs are different, so I know that I have to look for the number with the greater absolute value. The greater absolute value is 7, and the answer, therefore, is going to be a positive 4. Positive 4. All right? This should all be review from last year, so hopefully adding and subtracting are things that you're remembering. One little hint, these changes that I've made here, so you can see that I did it in a different color, I always recommend that you make those changes using your correcting pen. It's just something that I think helps you to visually check in that you've done both of these two things. So I like when you're working with positives and negatives, particularly with subtraction, make those changes using a correcting pen. I think it's the easiest way to just ensure that you've actually done it. It's like a visual checkpoint. All right, moving on to multiplication. I like to look at multiplication by using patterns. So if you take a look here, we know that 5 times 5 equals 25. 5 times 4 is 20. 5 times 3 is 15. 5 times 2 is 10. 5 times 1 is 5. And anything times 0, 5 times 0 is 0. A couple of patterns to look at. First of all, in the first column, you see we're multiplying everything by 5. In the second column, if you can think of this sort of as a number line, it's going in order 5, 4, 3, 2, 1, 0. So it's going down by ones. And in the third column where our product is, you can see too that this is like a number line that's jumping down by 5s. You can use those patterns to help you to predict what's going to happen when you start multiplying 5 by numbers as they continue on the number line. So as I go 5, 4, 3, 2, 1, 0, like you see in the top half of the problems, after 0, if I continue the pattern, I would be into the negatives. Negative 1, negative 2, negative 3, negative 4, and negative 5. And in the third column, if we continue this pattern of going down, 25, 20, 15, 10, 5, 0, the next number that would come in order would be negative 5, negative 10, negative 15, negative 20, and negative 25. And now when I look at those values, I'm thinking to myself, well, Here I had a positive value, and I multiplied my positive value by a negative, and the product of a positive and a negative turned out to be negative. In my top half of the problems here, nothing you guys don't already know, a positive number times a positive number is equal to a positive number. Another kind of interesting way to think about multiplication is we know that multiplication is repeated addition. So if I think about what 5 times negative 1 means, 5 times negative 1 essentially means negative 1 plus negative 1 plus negative 1 plus negative 1 plus negative 1. I know that negative 1 plus negative 1 plus negative 1 plus negative 1 plus negative 1 equals negative 5. So this is just another way to think about why it is that a positive times a negative equals a negative. All right, let's talk about now what happens when we multiply more with negatives. So as we said, since a positive times a negative is a negative value, commutative property would tell us that a negative times a positive would also be a negative value. And so negative 5 times 5 would be negative 25. Negative 5 times 4 would be negative 20. Negative 5 times 3 would be negative 15. Times 2 would be negative 10. Times 1 would be negative 5. And 0 property tells us that anything times 0 will always equal 0. Interesting sort of pattern here, because if we look again in the columns, first column, all values are negative 5. Second column, numbers are going down, 5, 4, 3, 2, 1, 0. And in the third column, this is where it gets interesting. These numbers, negative 25, negative 20, negative 15, negative 10, negative 5, and 0, are all getting closer to 0, which means that these numbers are not getting smaller. They're actually getting bigger, because as we go from negative towards 0, the value is actually getting larger, which means that if I take a look at the second half of the problems on the page and I continue this pattern, negative 25, negative 20, negative 15, negative 10, negative 5, 0, the next 5 numbers that fall into line are 5, 10, 15, 20, and 25. Which means that when I take these negative values and I multiply them by more negative values, the product actually gets larger and turns into a positive value. Here we already know, because of commutative property, that a negative times a positive will equal a negative. When you have a negative number, the smaller the value that you multiply it by, the larger its product is going to be. All right, and finally, we're going to finish today with some division. Division rules are the same rules as multiplication. Same rules as multiplication. So if I know that a positive times a positive is equal to a positive, I can take any division problem and turn those facts back around into a division problem. So I can take 3 times 4 equals 12 and rewrite it as 2 division problems. 12 divided by 3 equals 4, or 12 divided by 4 equals 3, because they're all part of the same fact family. What you see here is that a positive divided by a positive obviously will give us a positive. Same rule as with multiplication. If I take a look in the next column over, I've got a negative times a positive, negative 3 times positive 4, which we know is equal to negative 12. If I turn those facts back around into a division problem, look what I've got. Negative 12 divided by negative 3 leaves me with positive 4. And negative 12 divided by positive 4 leaves me with a negative 3. So I see here in the top example that a negative number divided by a negative number is equal to a positive, and a negative number divided by a positive number is equal to a negative. And finally, in the last example, let me just divide this so it's easier for you to see. A negative times a negative equals a positive negative 3 times negative 4 is equal to positive 12. If I turn these facts into a division problem, I've got 12 divided by negative 3 equals negative 4. And 12 divided by negative 4 equals negative 3. So again, a positive divided by a negative gave me a value that is negative. So our rules for division and our rules for multiplication are exactly the same. And it's basically this. When the signs are the same, the answer is positive. When the signs are different, the answer is negative. When the signs are the same, the answer is going to be a positive. When the signs are different, then that's going to give me a negative value. And there's one exception to that rule, and here's what that is. The exception to the rule is a situation like this. What happens when I multiply something like negative 1 times negative 2 times negative 3? Now I'm thinking back to what I know about my order of operations, and if I work the problem from left to right, I know that negative 1 times negative 2 actually equals positive 2. And now I still have to multiply that positive 2 times a negative 3, and now my answer is negative 6. So when we use a rule like when the signs are the same, the answer is positive, that isn't going to be true in this kind of a situation. It's only going to be true when you have an even number of numbers that you're multiplying. Here, because I have 3 numbers that are being multiplied, that third number is like an outlier, and it's going to turn my answer into a negative. We will obviously review these more in class, but this is hopefully just a little helpful tip to help you to remember all that you learned last year about adding, subtracting, multiplying, and dividing with positives and negatives. All right, hope it was helpful.